Good day, my name is Hermanus Albertus Maree, student number 606-73583, and today I'm presenting my practical submission for INI 3601. The project is based on a 5-level PLC controlled elevator, which in this case the structure consists of 3 different sections. We have our base sections, which is for the stability of the project and will also be housing our 24-volt DC supply. We have our elevator section where the cab for the elevator moves up and down. And then we have our control department section, which will contain all the control equipment. For control equipment, we have our Siemens logo 24-volt PLC along with the expansion module. We'll have our 2 amp fuses for protection of the PLC. We have our 5-volt power supply for the control of the system. We have our 12-volt power supply for motor 1. We have our speed controllers for motor 1 and motor 2, which will control the speed that it operates at. We have our 24-volt distribution block, 5-volt distribution block, and ground distribution block. We'll also have motor 2 and motor 1 controllers, which will control the forward and reverse movement of the motors. At the back, in our elevating compartment, here we'll have our elevator rack, which is for stability of the cab. We'll have our hoisting rope, which will hoist our cab up and down. On top we'll have motor 1 for the hoisting of the motor, our hoist motor. And then in the corner we have our over temperature circuit, which will measure the temperature inside the elevator, and at 35 degrees Celsius it will go into a critical state. For this project I've added a potentiometer meter just to adjust the reference temperature, just to send it into a critical state. Okay. At the front, we'll have our level identification light, our emergency light for when it goes into over temperature, and on top we'll have our over temperature alarm. Okay, we also have a push button for each floor that can be called for when necessary. Okay, switching on the project, the level indicator will indicate that the cab is currently at the ground floor, which is floor level 0. When calling for floor 3, the cab will start to move up. As it passes each level, the level indicator will display the specific level. Okay. At floor 3, it will stop. The doors will open after 2 seconds. Reach the limit switch, stay open for 3 seconds, and then it will start closing again. Okay. Calling floor 4. At floor 4, everything will happen as with 3. Just want to reset the slide. Apologies. Okay. For demonstration, I will adjust the reference for the temperature to so that the circuit will identify that there's over temperature in the cab. The buzzer go off, the light will go on, and the cab will automatically move down to the ground floor. Okay. Okay, here the door will open, the buzzer will switch off, and the light will stay on, and the door will not close as long as it's in this state. At this point, any button can be called, the elevator will not react to it. Going out of this state, the light will switch off and the door will automatically close again. And everything will operate as normal. And this is my submission for INI 3601, and I thank you for your time.